So in this question here, I've got an equation, y times cotangent x to the power of 4 equals x times cosine of y cubed. We want to find the derivative of y with respect to x. Now here, to express our y in terms of x explicitly, it's not going to be easy because we've got cosine of y cubed here. So y is expressed implicitly in terms of x because it's all mixed up in the form of an equation. Now we want to find a method to solve that, and we're going to use implicit differentiation. That's what we're going to use. So our setup first of all is to take the derivative of y with respect to x of both sides. So let's do that. So the derivative with regards to x of y times the cotangent of x to the power of 4 equals the derivative with respect to x of x times cosine of y cubed. So that's our setup. Now I've got y here and cotangent here and x here and cosine here. So I'm going to need something called the product rule. So the product rule, our setup for that is if I write to take derivative of two functions multiplied together, so f and g are the two functions, I want their derivatives. That gives me f prime g plus f g prime. So it's split up into two parts and they're added together. So I need to apply this to both sides of our equation to do that. So I've got y here and cotangent x to the power of 4 here. So I'll let f be my y and cotangent function to be my g. So f prime. So derivative of y with respect to x, well that's just dy dx. So I'm going to write that at the back. So I don't want to write dx at the front. I'll show you why in a moment. And then I want g, which is just this function here, cotangent x to the 4. So that just stays as it is. So cotangent x to the 4. Now if it had written dy dx at the front, it would have looked like I want to take the derivative of cotangent x to the 4, but I don't. I just want to represent the derivative of y. So that's the first part. Now the second part is f, well that just stays as y, so that's plus y, times the derivative of my cotangent. Well, the derivative of cotangent is minus cosecant squared. So if I write cosecant squared, the input will stay the same, but by the chain rule I need the derivative of the input of x to the 4, which is 4x cubed. So I need to write 4x cubed here and the minus sign from the derivative of cotangent. So I can now change this to a minus sign, so that'll take care of the minus, and I'm just going to write 4x cubed here. So I can rearrange that in a moment. That just shows what I've achieved by this side. Now I'm going to set it equal to the derivative of this one. Now x cosine y cubed. Well, the derivative of x, that's just 1. So I've got 1 times cosine y cubed, just leave the function as it is. Okay, so that's that first part taken care of. Now I need the second part. So I could just write my function x. So I'm going to add x and then take the derivative of the cosine y cubed. Well, the derivative of cosine is negative sine. So I can put sine here, change that to a negative. So that gives me all my negative sine part. Now the input will stay as y cubed. And then by the chain rule, now there's two parts of the chain rule here because I've got y. First of all, the derivative of y cubed is 3y squared. So I'm going to write that's 3xy squared. And then again by the chain rule, because I've got y, I need to put a dy dx. So dy dx. Okay, so that's our first part of this bit calculated. So our next goal is to isolate terms with dy dx. So this one here and this one here. So we get all those onto the same side. So I'm going to write the dy dx at the back again because I don't want it looking like I'm taking the derivative of if it's in the front. So I'm going to write this one here, cotangent x to the 4. So cotangent x to the 4. Bring this one over to the other side. That becomes positive 3xy squared. So that's plus 3xy squared sine y cubed. And now, because I've factored out the dy dx effectively, I can now put dy dx. So now all I need to do now is put this terms without the dy dx on the right hand side. So let's put this one in first as it's already there. So 1 times cosine y cubed, just cosine y cubed. That's all good. Bring this one across. So I'm going to need to add. Now I'm just going to tidy up this bit here. So I've got 4. So I always write that bit first. Now I like to write my x's in front of my y's. So I'll have x cubed y. And then cosecant squared x to the 4. So that takes care of all of that. Now the goal is to get dy dx. That's what we're looking to find, is this bit here. So to find that, if I can isolate dy dx from this equation, that's simply my answer. So let's do that. So if I divide both sides by this inside here, my dy dx will be isolated. So divide this side by that just becomes 1. So that leaves me with dy dx. And then I've got this term on the right hand side here, cosine of y cubed plus 4x cubed y cosecant squared x to the 4. And then this one will then go on the denominator, as I'm going to divide this side by that. So I've now got cotangent x to the 4 plus 3xy squared sine y cubed. And that takes care of the result of my implicit differentiation of finding dy dx. Okay.